Hi guys, welcome back to another video tutorial. So in this tutorial we'll be going through an A-level topic. So this is going to be targeting for the new A-level maths syllabus. So for those of you who are doing the AS maths and A-level maths, this is going to be for the new syllabus that I'm going to do, so the pure mathematics. So in this topic we'll be going through trigonometric identities now and on how to solve an trigonometric identity equation. Now if you feel that you need a bit more practice on the basics on how to do this, put it down in the comments if you want me to go through that, and I can do that, no problem. But if you feel you're comfortable, then I guess this should be okay for you guys to try and tackle. Also, if you are struggling with certain topics, whether it be GCSE or A levels, or if you need to go through certain exam questions, I'm now doing something called Arithmetic A and E on demand, which is basically answers and explanation. And the way this works is through online, Skype, and no, there's no videos or anything like that. Basically, it's just the way you're doing now, where you're watching it, the way you're watching the YouTube video. So you'll be looking at a screen, and it's going to be in real time. And it will be me kind of writing the questions, and then you telling me what to write and how to, telling me the explanations. And this is, you should see this more as a on-demand thing. So just like, for example, I don't understand, I don't know, differentiation or stationary points or vectors or integration. You list the topics and then you book a session for 1 hour and then we go through that. And then that's it. You don't have to do this every week. It's something that you just do when you need it. And that means you come in, you do it, and you get out kind of thing. So it's just more effective that way. So if you feel like, you are struggling with certain things, that is also available to you. So let's get straight to the question. So this question is asking us solve the equation 2 cos squared theta minus cos theta minus 1 equals sine squared theta, and we have to have theta in the range of 0 to 360. Now for this topic, for trigonometric identities, there's two identities that you need to know for when you're doing AS mathematics, right? And these two identities, let me write it here, is basically sine squared theta plus cos squared theta. That will be equals to 1, or they'll say equivalent to 1. And then the other one is tan theta is equals to sine theta over cos theta. Okay, so for those who are doing first year AS maths, the pure maths, these are just the two identities that you need to know for this topic. You don't need to know any other topics. Now for the further maths people and people who are doing the second year, I guess you know how many identities there's going to be. Okay, now what I'm going to do first is I'm going to rewrite this equation. So let me rewrite this equation. So I'm going to have 2 cos squared theta minus cos theta minus 1 equals sine squared theta. Okay, now what I'm going to do is, you can see you have cos theta and sine theta, and we can't solve this when we have two different, cos and sine. So the option is you either make everything in terms of sine, because then you can find sine theta, or you make everything in terms of cos. But what I'm going to do, if you can see already, there's two cos already here, right? So we can't change this really into a sine. So what I'm going to do, you see this, you see the sine squared theta. Why can't we change this into cos squared theta using the identity? And I'll show you how to do that. Because if you change this into cos squared theta, everything is in terms of cos, and then you can solve it. Does that make sense? It's like saying if you have an equation in terms of, x and y, you want to try and put everything into x or y before solving it, like a quadratic simultaneous equation. So what I'm going to do here is I'm going to keep 2 cos squared theta here minus cos theta and minus 1, and I'm going to change sine squared theta, so using this identity. So basically what this means is, if you make sine squared theta the subject, what would be my new equation? So if I make sine squared theta the subject, because I want to know what sine squared theta is, okay, that basically means this cos squared theta moves to the other side. So you're going to have 1 minus cos squared theta, okay? And that now, instead of writing sine squared theta, can you not just put 1 minus cos squared theta? Do you guys see that? And can you see now, look, everything's in terms of cos. So now I'm going to bring everything to the left-hand side so we can get a quadratic. So I'm going to have 2 cos squared theta minus cos theta minus 1. And then if you bring 1 to the other side, it becomes minus 1. And if you bring minus cos squared, it becomes plus cos squared theta. And that is going to be equals to 0. So now if we simplify this, 2 cos squared theta Okay, that's a theta. Okay, that's not meant to be a 0. So 2 cos squared theta minus cos theta. Oh, no, 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 no. I forgot something, isn't it? You could just simplify this. 2 cos squared theta plus cos squared theta is 3 cos squared theta. Okay? So that's 3 cos squared theta. And then minus cos theta. And then minus 1 is minus 2 equals to 0. And now you can see you have a quadratic. Can you not see this can be also written as 3x squared minus x minus 2 equals 0 if you say that x is equals to cos theta? Isn't that the same thing? Right? And now what you need to do is you need to solve this. So I'm going to solve this like this, or if you feel like you're a bit uncomfortable with the cos theta, you could just factorize this with x. Okay, now how do I factorize this? I'm sure you know you just want two numbers. When you multiply, it gives you 3 times minus 2, which is minus 6. And two numbers, when you add, gives you the number before cos theta, which is minus 1. It's the same thing here. Think about it like this. Two numbers when you multiply gives you minus 6, and two numbers when you add gives you minus 1. So that's just going to be minus 3 and 2, minus 3 and 2. Now what I'm going to do, the reason why I'm going to do it this way is going to help when you're going to do proving of identities as well, as opposed to this. But if you feel a bit uncomfortable with this, you can always factorize in this method. So now what I'm going to do is I'm going to write 3, well, I had so much space here. Okay, right, so I'm going to write 3 cos squared theta. These two values, I'm going to bring them here, but I'm going to add cos theta to them at the end instead of x. So it's going to be minus 3 cos theta plus 2 cos theta, and then we bring minus 2 down. This is just a factorizing method, but instead of x, we have cos theta. Now, what can I take out here? What's in common? 3, but also cos theta. So you have 3 cos theta, and then inside basically it's just going to be cos theta, because cos theta times cos theta is 3 cos squared theta, and then minus something times cos theta gives me 3 cos theta, is just going to be 1. And then here we can just take out plus 2. So we're just left with cos theta minus 1, because you're dividing everything by 2, right? Equals 0. Now we can bring our bracket, so we have 3 cos theta plus 2, that's in one bracket, and then the other one is cos theta minus 1 equals 0. Now what we're going to do is, because we're going to find cos theta, so we have one solution where it says 3 cos theta plus 2 is equals to 0. So now if we want to find cos theta, bring the 2 to the other side, becomes minus 2 and divided by 3, so it's minus 2 over 3. And then this one, we have cos theta is equals to 1. Okay, now you need to find the values of theta, right? And I'm going to do this using the diagram. Now, if you know using the cos diagram, you know, that's fine. But I feel like for me personally, in my opinion, and the students that I've taught, they feel that the diagram is easier. Okay, so what we're going to do is we're going to find thetas. Well, we're going to find the values of theta for these two solutions. Okay, now how I'm going to do that? Okay, let's draw the graph here. So if we have, okay, we're going to use another color, it will be better. So if so again, this is just not going to be accurate at all, so apologize here because it's not going to be straight. So first and foremost, I'm going to do cos theta equals minus 2 over 3, right? So I'm going to do this one here. So I'm going to have, let's put cos theta is equals to minus 2 over 3. So this is for this graph. Now you should know your cos theta graph, right? How it looks like. So it's going to be something like that. Okay, again, not very accurate, I know. So this is going to be 90, this is going to be 180, this is going to be 270, and this bit is going to be, well, this end bit is going to be 360. Now what I would say is just give this graph a go. See first if you understand it. Okay, if you don't understand it, then stick to the cos diagram. Okay, but if you understand it, it's not as hard as it looks, the graph, and it's actually very easy once it's a pattern. It's really a pattern, that's all it is. So see if you understand this explanation for graphs on how to get the values of theta, and if you don't like it, don't do it and just stick with the method that you're comfortable with. Right, so I think everyone knows this is a cos graph. This is 1 obviously, and this is going to be minus 1, the maximum and minimum value. Now if we want to sketch cos theta equals minus 2 over 3, right, I need to put minus 2 over 3. That's the same thing as saying y equals minus 2 over 3, right? So I know that that line is going to be somewhere here. So let me use should I use a red line, I guess? So that's going to be somewhere here, right? Minus 2 over 3 because it's negative. So that's here, but can you see that there is two intersections with the red line and the orange line, if you like? there's an intersection here, and there's an intersection here. These are basically your theta values that you need to find, and that's why it's asking for this bit. So if we get this value, theta value, that first theta value you can find by inversing this. So let me I think I'm going a bit quickly here. What I'm saying basically is cos theta equals minus 2 over 3, and we're sketching this, right? This is minus 2 over 3. And then you have two intersections here, one and one here. Now we can find the first value of theta here by doing inverse cos of minus 2 over 3. So if you do inverse cos of minus 2 over 3, that should give you, let me just quickly check that. That should give you 131.8. So that will give me 131.8. That is my value for the first one. That's my first value. So this bit is going to be 131.8 degrees. Okay. Now to get this intersection here, what you need to do first is, can you see if this is 90 and this is 131.8, can you not find the difference first between these two? The difference between 90 and 131.8. How far is it going from 90 to 131.8? So to do that, you just find the difference, right? So if we do 131.8 minus 90, that should give you what? 41.8. So the difference is 41.8. Okay, this difference. So that's 41.8. That's the difference. Whoops. So if the difference is, so let me just write that there. Difference is 41.8 degrees. So if I know that from 90 it's going 41.8 to 131.8, so it's going 41.8 this way. For me to get this angle, right, let me use a different color pen here again. So for me to get this angle, I know this is 270. I need to go backwards 41.8 from 270 to get this intersection. No? So I need to do minus 41.8 this way. So what I'm saying is to get the other intersection. So what I'm saying is you do 270 minus 41.8, the difference, because this difference is the same as this difference, right? So if you do 270 minus 41.8, that just gives you 228.2 degrees. Okay, so your angle for theta for this one is going to then be, you're going to have 228.2, that's 1, and then the other angle that we find is 131.8 degrees. Okay, so I hope people understand what I've just done on the graph. So if I just quickly explain again, you first draw your cosine graph, right? And then what you have is cos theta equals minus 2 over 3. So you sketch your minus 2 over 3, which is that red line. And then you can see the intersection points, the two intersection points. Those are the two intersection points that you need to find the angle. Now, to the first intersection point, you can actually find from the original here by finding inverse cos minus 2 over 3. So you know that's 131.8. That's your first angle here. But then for you to find this angle, if you find the difference between 131.8 and 90, this difference, that difference is going to be the same as this difference here. So if you know that it's going 41.8 this way or up, for you to get from 270 to this breadpoint, you're taking away 41.8 because the difference is constant. And that's it. That's all you do to find the angle. Okay, so now if we go to the second one, again, I don't know if this kind of if you don't understand this and if you need a bit more kind of explanation, put it down in the comments and I can just do a video on just the graph, just so that you know it's just focused on that, and then I can go in more detail. But really, this is how it is. But if you feel like you need a bit more slower, just put it down in the comments and I can do that, no problem. Now if we do the other graph is a lot more simple, and I'll tell you why. So I guess this is the first graph. And you can actually do in both graphs. You can do both of them as both graph, but I think it just look a bit messy if you do it all in one. So we're going to draw another cos graph again, right? And we know that this is going to be 90, this is going to be 180, this is going to be 270, and this is going to be 360. Okay, now the other value that we have here is cos theta equals 1. So I'm just going to have cos theta is equals to 1. Oh, I forgot, this is 1 and minus 1. Cos theta equals 1 is going to be where is that going to be basically if we were to draw a line cos theta equals 1? Do you think? I know my graph is not very accurate, but that's just literally going to touch that line, isn't it? You see, 1. That's where cos theta equals 1, where it just intersects the 1. So if you look at your intersection point, you have 1 here, and you have 1 here. And obviously this is meant to be down to 360. So you can see straight away from the graph, you don't need to do any of this because this is straightforward. The theta value for here is going to be 0 because that's your angle here at 1 is 0. And this other intersection is going to be 360. Do you guys see that? That's all you do on this one. So your final angle, then your final theta values for your answer is going to be 0. You combine both of them, 0, 131.8 degrees, 228.2 degrees, and the final value is, aha, did it say 360? Okay, you got to be careful here. We've put 360 here, isn't it? But if you look at the range, again, we can't have 0 and 360 because it's not equals to. So in this case, we can't use 0 nor 360. Do you guys see that? So your actual final value then is going to be not 0 and 360. So wait, you got to be careful. So you got to be careful and look at the range, right? So your actual theta value, because there's no equal sign, if there was an equal sign here and here, you're going to have to include 0 and 360, which is this. But these two values are not in the range. So your actual value of theta is just going to be 131.8 degrees and 228.2 degrees. And that is your answer. So be very careful. See, I forgot about the range as well. I assumed there was going to be equals. There is no equals, which means you can't include 0 and 360, right? But you still have to show the method of how you get this. So this is in the range, this is in the range, and these two are not in the range. So your final value for theta is this. Okay, so hopefully you've taken something from this video and you understand how to kind of solve these trigonometric identity questions. The first thing is you obviously need to know what identity to use and then get this into a quadratic and then solve the quadratic. And then again, if you don't like the graph diagram, you can use a cast diagram to find your angles. Now if you feel like you need certain, you know, certain kind of go through over certain things here, put it down in the comments. Anything you don't understand, put it down in the comments and I will be more than happy to help you guys out. Okay, so that will be a wrap for this video, and I shall see you on the next one. Oh, and just put some topics that you want me to go through, by the way, in the comments. Things that you want me to go through for pure maths, for the new syllabus. Okay, and yeah, I shall see you on the next one.